Hi. Hello everybody and welcome. I'm Grace. Nice to meet you. Efacec is Portugal's market leader in integrated solutions in 3 fields of expertise: water, air treatment and solid waste. Its activities cover all the cycle from the design and construction to the operation of several environmental systems such as water treatment plants, WTP, wastewater treatment plants, WWTP, industrial divesting, heat ventilation and air conditioning, HVAC, helicontrol and solid waste treatment plants. The following video shows the different stages of a wastewater treatment plant. Domestic and industrial wastewater are mostly contaminated with organic matter, solids, and nutrients. This wastewater is transported by a network of pipes to a wastewater treatment plant, commonly called WWTP. In order to be treated and achieve a quality suitable for reuse or discharge into the environment, thus preserving natural water resources. Raw wastewater gets to the inlet chamber of the WWTP and is pumped by Archimedean screw pumps for preliminary treatment. Initial pumping may not be required, depending on the type of hydraulic installation. The wastewater is first strained to remove all larger solids. Generally, there is a coarse screening before the fine screening to prevent damage or clogging of the equipment. The solids collected in this stage are removed and later disposed in a landfill. WWTP can also be prepared to receive septic sludge when equipped with a compact pre-treatment unit. After the removal of the larger solids, the effluent enters the grid, or grease chamber, where sand settles, and floating materials such as grease and oils are skimmed off. This tank is equipped with air injection system that allows the flotation of the grease to the surface and, at the same time, promotes the separation of organic matter from the sand. Pre-treatment is followed by primary treatment, which may be carried out in primary settling tanks, lamellar, or conventional, to reduce the content of solid particles in the effluent, with expected removal efficiency of 50 to 60% for suspended solids and of about 20% for BOD5. The sludge produced in the form of primary sludge will be separately treated or processed in the solid line of the plant. The clarified effluent is then ready to undergo biological treatment. The bioreactors may have many different configurations, depending on the parameters and procedures required and on the contaminants to remove. In this case, we have an oxidation ditch with air and anoxic zones for removal of carbonaceous matter and nitrogen. There are WWTP, where only the carbonaceous matter is removed, and others more complete, which also include the biological removal of phosphorus. In all cases, the treatment is based in the growth of microorganisms, referred to as biomass, which will feed on the water contaminants. To allow the biological treatment to achieve the desired removal efficiency, it is essential to ensure adequate levels of oxygen in the biological reactor. This is because most microorganisms are aerobic and use oxygen in their metabolism. Oxygen can be supplied by various means, all of which involving significant energy consumption. In this case, the plant is equipped with blowers associated to a diffused air system. After the biological reactor, the mixed liquor, which is a mixture of biomass with the effluent, enters the secondary clarifier to promote the separation of the treated effluent, which is removed through the surface wears, from the biomass that settles at the bottom of the tank. The solid phase removed from the secondary clarifier is called secondary sludge or biological sludge. A part is constantly recirculated to the biological reactor by pumping in order to maintain an appropriate balance between the population of microorganisms and the pollutant load. The excess biomass is removed from the system and sent for biological sludge thickening. To complete the liquid phase treatment, the effluent is carried through a microscreening to reduce the level of suspended solids, and is disinfected afterwards by the action of lamps that emit ultraviolet radiation. Contamination of pathogenic bacteria can be reduced to levels that allow reuse of the effluent for irrigation and washing purposes. The sludge resulting from the wastewater treatment must undergo several stages until it is converted into a dewatered and stabilized sludge. Regarding primary sludge, gravity thickeners are provided to increase the solid's content. For biological sludge handling, mechanical processes such as thickening tables, thickening drums, or flotation thickeners are the most adequate. The thickened sludge, both primary and biologic, undergoes an anaerobic digestion process. For that purpose, anaerobic digesters in the plant are equipped with the necessary systems for mixing, heating, and biogas collection. The aim is to remove about 50% of the sludge, volatile matter through a process of low energy consumption, and at the same time to produce a biofuel known as biogas. The temperature is a critical factor in anaerobic digestion, and it is necessary to keep the sludge to about 35 degrees. Therefore, the plant has a heat exchanger where the sludge to be heated, and hot water from a boiler or cogenerator circulating countercurrent. Emphasis should be put on the fact that water heating is accomplished by recovering the thermal energy obtained from burning the biogas. The digested sludge is dewatered in centrifuges, giving place to a manageable solid residue with a dry matter content exceeding 20%. Polyelectrolyte, prepared in automatic units, is used on sludge conditioning. If a problem occurs in anaerobic digestion, and sludge is not adequately stabilized, a chemical stabilization may be accomplished by adding lime. The dewatered sludge is now ready to be stored and transported to an appropriate destination. Sludge is discharged from the silo gate valve directly to the trucks, which then pass the width bridge to register the quantity produced. This sludge is commonly used in agricultural. For periods during which larger quantities of sludge must be stored, a sludge storage building may be used. Biogas produced during anaerobic digestion of the sludge is stored in gas holders. Excess biogas is burned in a flare, thus preventing the release into the atmosphere of gases that contributes to the greenhouse effect. The main objective of the biogas production is to provide a biofuel that can be used in engines for cogeneration in order to produce electricity and thermal energy, bringing major environmental and economic benefits. The wastewater treatment plants consume energy, and the power supply is ensured by an electrical power substation that receives energy from the public medium voltage network. For odor removal, the WWTP has odor treatment systems, chemical or biological, which control the compounds responsible for the bad odors, such as H2S, mercaptans and ammonia. To ensure the proper functioning of all treatment stages, the plant has a control and supervision center, located in the operation building. Through it, it is possible to monitor all the process variables, and to adjust the equipment functioning to the specificities of the wastewaters to be treated in real time. In short, a plant is no more than a factory, which receives polluted wastewater as raw material and transforms it into treated water that can be discharged in the receiving environment without causing negative impacts, and can even be reused for various purposes. The wastewater treatment plants are therefore essential infrastructures, which allow us to maintain the quality of life of the societies and to preserve the environment for future generations. Well, I hope you enjoyed our video. Goodbye, until the next one.